Okay, last lesson we looked at graphs of sine and cosine, and we figured out how to find the important parts of it. Those important parts included the amplitude, which is the height of the graph, the period, which is how many times it takes to repeat itself, and then the midline, which is kind of just the middle of the graph, which is sometimes above, sometimes below the x-axis. Today we're going to look at how can we change the graph. Okay, so we were looking at sine and cosine. Sine, the parent function of sine is just y equals sine x. It's the most basic form. But what if we don't want a basic form? What if we want to make changes to it? Well, the full form is y equals a times sine of bx plus c plus d. Okay, and usually in the parent function that x would be in parentheses. Okay, that's the input. All right, so there's an a, a b, a c, and a d. Those are all just constants. Those are going to be numbers. They might be 0, they could be 0. A and B can't be. But those are just numbers, so we could put numbers in any of those 4 slots. Okay. And cosine of x is the parent function, or you could have the general form with the a, b, c, and d inserted. Okay, so we're going to be able to find all of the same important features, but without a graph this time, just given an equation. The first is the amplitude. Remember, the amplitude is just the height of the graph from the middle. Okay. The amplitude, if you're just given the equation, is the absolute value of A. Okay. If you remember the longer formula, you use max minus min divided by 2. But again, we're not going to be given a graph. We're just going to be given an equation. So if you know the equation, the number in front, the A value, is the amplitude. It is absolute value. Amplitude is always going to be positive. What if your A value is negative? If your A value is negative or less than 0, then it's reflected over the x-axis. Okay. Meaning that it just starts differently. Sine, instead of going up and then down, goes down and then up. Cosine starts at a minimum instead of starting at the maximum. And one thing to note is that amplitude does not affect the shape of the graph. All it does is affect the height. Okay, so nothing else is changing in amplitude. If your amplitude's not 1, it just means it's going to go higher or lower depending on what the A value is. Okay, so in this example we have 3 separate sine graphs. We got sine of x, 1/2 sine of x, and -3 sine of x. That first one, sine of x, has an amplitude of 1, an A value of 1. The second one has an A value or an amplitude of 1/2. And the last one, j of x, has an amplitude of 3. It has an A value of -3, so the absolute value of that is +3. And that just means it's reflected. So this one's going to change direction a little bit. All right, but all these periods are the same. Remember the parent function period is just 2 pi. So we're going to start with labeling our y-axis. We're going to have to go up to 3 at the maximum and down to -3 for the low. And like I said, the period is staying the same, so I'm going to put 2 pi over. We're just going to draw one period. Half of that is 1 pi. And then half of those, I'll put those in. Pi over 2, and then 3 pi over 2. Again, these are just quadrantal angles. Okay. So graphing sine x, remember it starts at 0. Sine functions start at the midline. Goes up to the max, back to the midline, down to the min, back to the midline. That is one full period of sine. We'll connect the dots. It's a pretty good line. All right, the second one, 1/2 sine x. So that means the only thing that's changing is those mins and maxes aren't going to go as high. It's going to be half. It's going to go up to a half and down to -half. So this one's just kind of a shallower, more compressed version of the parent function. And then the last one. Now again, instead of going up, because A is negative, we're going to start by going down. So we're going to go down to the min, which is -3. Back to the midline, up to the max, back to the midline. So that is how amplitude changes your graphs, and how to find amplitude from given an equation. Finding the period. Remember that the period is the distance it takes for points to start repeating themselves. So how far is it between the max and the max, but the min and the min, the starting points? Distance between any repeating points. To find the period, if you're given the equation, it's going to be, I use P for period, it's going to be 2 pi, which is your normal, your parent function period, 2 pi divided by the b value, the absolute value of the b. Okay. Again, those are absolute value, so it's always going to be positive. Your period's always going to be positive. So 2 pi divided by b. Now, on your graphs, there's the points we use, we call them critical points. We need 4 of them. So to find the critical points, you just take the period divided by 4. Okay. And those are going to be kind of what we use to create our graphs. All right, so in this example, we have 2 cosines. We have parent function cosine, and we have cosine of x over 3. Okay. So we want to find the b value. So again, a value is to find the amplitude. The b value helps you find the period. That first one is just the parent function, so it has a period of 2 pi. Okay, 2 pi divided by 1. The second one, cosine of x over 3, can be rewritten as 1/3 x, which means your b value is 1/3. So we're going to use that 1/3 to find the period. Okay, remember, period is 2 pi divided by b, so this is going to be 2 pi divided by 1/3. Which is 6 pi. Okay, so our period is 6 pi. So it's going to take, to go 1 full cycle, it's going to take 6 pi, where usually it takes 2 pi. Okay. So on the edge of our graph, we're going to put 2 pi on the right side. And we'll label the y-axis, the amplitude for both of these is 1. Halfway between 0 and 6 pi will be 3 pi. And then I'm just going to put 1 pi as all of our marks. So 1 pi, 2 pi, 3 pi, 4 pi. 5 pi, 6 pi. I'll label those. All right, now I'm going to start with the g of x, the 1/3 part. It's cosine, so it starts at the max, and then it's going to end at the max. Okay. Halfway between them, it's going to go to the min, which is -1. And then halfway between those, the mins and the maxes, which aren't marked on the graph, that's when it's going to hit the midline. This is kind of a longer graph. It just starts up, goes down, back up. That's 1 period. Now let's graph the parent function just to compare. The parent function repeats itself every 2 pi. So every 2 pi is going to be a new max. Between those is going to be your min. And then we don't need the midline parts, but it goes down and then up. That should have hit. Down, up. So this one fits 3 full cycles. So there's 3 full periods of the parent function, whereas there's only 1 period of the 1/3 x. Okay, so that b value kind of stretched it out a little horizontally. Frequency, we're not going to deal with a lot, but the frequency is, like we said in the last lesson, the inverse of the period. So if you know the period, 1 divided by the period is going to be your frequency. Or it has its own formula. It's just the period formula flipped over. Absolute value of b divided by 2 pi. That'll tell you the frequency. Again, we're not going to find that. The phase shift, this is a new one. We didn't do this in the graphing lesson, but we're going to do it in this one. It's the horizontal shift from the parent function. So we saw the graph move up and move down, but we never saw it move to the side. So this is the horizontal movement of the graph. I like to think of it as a new starting point. Okay. Cosine functions start at 0, and sine functions usually start at 0. But with a horizontal shift, we're going to, wherever the new starting point is, that's where we're going to start. There's a formula to find the phase shift. Again, all of these have to do with the A, B, C, and D from the general form. The phase shift, I use PS. It's the opposite of C, so -c divided by the absolute value of B. So the opposite of C, or -c divided by B. That's your phase shift, and whatever value that is, that's going to be your new starting point. All right, so in this example, we have y equals sine of 3x minus pi over 2. I'm going to start by labeling A, B, and C, and D. A is 1, number in front. B is the number in front of x, 3. C is the number kind of added and subtracted to the bx part, which is pi over 2, and there is no d value. So we'll start by finding the amplitude. The amplitude is the absolute value of A. The absolute value of A is the absolute value of 1, and the absolute value of 1 is just 1. The period, 2 pi over B. Our B value is 3, so it's going to be 2 pi over 3. Next up is the phase shift. B over C. Or no, flip that. C over B. Opposite of C over B. So it's going to be pi over 2 divided by 3, which is pi over 6. Okay, so that's going to be our new starting point. We're not going to start at 0. We're going to start at pi over 6. Okay, and we'll find the critical points as well. So the critical points are what we're going to use to graph. Critical points is going to be the period divided by 4. So 2 pi over 3 divided by 4 is 2 pi over 12, which is pi over 6. Okay, our amplitude's 1, so we only have to go up to 1 and down to -1. Okay. And since our critical points are pi over 6, I'm going to do a bunch of pi over, just every marking is going to be pi over 6. Okay. So pi over 6, 2 pi over 6, 3 pi over 6, etc. Okay. The problem said that we're going to do 2 periods, so we're going to need a lot of these. And again, I'm going to label it 2 pi over 6. You could simplify that to pi over 3, but just for ease, I'm going to leave it unsimplified. 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, etc. Just keep counting up pi's over 6's. Again, you could simplify these fractions if you want, but just for ease, I'm not going to. It's going to be 2 full periods. And 1 full period is 2 pi over 3, which is also 4 pi over 6. Okay, so every 4 pi over 6, it's going to repeat itself. Now look where we're starting. We're not starting at 0, we're starting at pi over 6 because of that phase shift. Okay, and then 4 marks over is going to be the second period, and then 4 marks over is going to be the end. Okay, so let's see, was this a sine or a cosine? Okay, because that's going to, okay, there's a sine. Yep. So we're going to start at the midline. And again, each period is going to repeat itself. So each of those marks is going to be at the midline. Start going up, back to the midline, down to the min, back to the midline, and then repeat it. Okay. Each critical point get its value, and then connect your dots. Okay. Now again, we didn't start at 0, but these graphs are waves, so they keep going forever, so you can connect that where it would be. Okay. But again, because of that phase shift, sine didn't start at the origin point. It shifted over. All right, and then last is the vertical shift of the midline. This is the d value at the end. If it's a plus d, your graph is going to shift up. If it's a minus d at the end of your equation, your graph is going to shift down. And that's just the midline. So whatever d is, that's the midline. The formula when we had the graph was max plus min divided by 2. Again, those will give you the same values, but we're assuming we're just given the equation, not the graph. All right, so in this last problem, we're going to state the amplitude, period, phase shift, vertical shift. Again, start by labeling A, B, C, and D. A is 1, B is also 1, C is 2 pi, and then D is minus 1. So this one will have a vertical shift. Amplitude's easy, just the A value. A value's 1, amplitude's 1. Again, that's from the A value. We'll go to the midline next. Midline is -1. Okay. Now, since it's a horizontal line, we usually write it as y equals -1, because it's not just a point, it's a line. The period, 2 pi over b. B is 1, so 2 pi over 1 is just 2 pi. And the phase shift. Again, phase shift PS. C over B. Okay, now again, B is also still 1. So anything over 1 is itself. So the phase shift is 2 pi. Now notice the period and the phase shift are the same. Okay, which means the graph's not really going to change at all. Because if it repeats itself every 2 pi. So if you start 2 pi to the right, it's going to be the exact same thing. All right, so we draw a dotted line on the midline. Our midline's -1. So now for our amplitude, when we go up 1 and down 1, we're going to go up to 0 and down to -2. A full period, we're going to do 2 periods, so we're going to need 2 pi and then 4 pi. And then again, just a rough sketch. We know sine goes up and then back to the midline, down to the min, back to the midline, and repeat. And sketch your graph. Okay, that's 2 full periods. Again, the phase shift on that one didn't matter a whole lot because it was the same as the period. And that's how you find everything from all the key features from an equation. Okay. Figure out what A, B, C, and D is. A is the amplitude, B helps with the period, B and C help with the phase shift, and D helps you find the midline.